Hey guys, so this is our reinforcement lecture. So we're going to go through this. We're going to try to complete part of this reinforcement worksheet together, and then we will look at how we're going to submit this. It says complete the diagrams below as indicated and answer the questions. The lines in figure 1 show magnetic forces acting between two pairs of bar magnets. Label the unlabeled poles of each magnet with N for north, S for south between the unlike poles. So this is, they're repelling one another. So if this is south, then this one is also going to be south. Here they are attracting one another. So if this is south, this is going to be north. What generalizations can you make about the reaction between like poles and then between the unlike poles? Like poles repel each other. Unlike poles attract each other. So here, on figure 2, draw lines of force around the bar magnet as they would appear if you sprinkled iron filings on the magnet. So we're going to try to do this as a class activity when we get a chance. But the idea is it's going to be really strong here. These iron filings are going to be really here, really strong. And we might have a few way out here. We're going to find a lot of magnets right in, or a lot of iron filings right in here. That's what it's going to look like. And that's going to be the magnetic field. We're not going to find very much in here. Where are most of the iron filings located? They're going to be most are at the poles. They spread out at the center. So what can you infer about the strength of the magnetic field based upon the position of the iron filings? It is strongest at the poles. So we're going to have to look this part up in the book. But what 3 materials can be used to make a magnet such as the one above? It's cobalt, nickel, and iron. So let's go to the second page. When a current is passed through a coil of wire with a piece of iron inside, what are we making? We are making an electromagnet. An electromagnet, we can turn it on and off because we can turn the electricity on and off, so it's a temporary magnet. Adding more turns to the wire coil will increase the strength of the electromagnet. By the way, if you increase the electricity or the current going through those coils, you will also increase the electromagnet. Number 4, increasing the amount of current that flows through a wire also increases the strength of the electromagnet. Electromagnets change electrical energy into mechanical energy because you can magnetize things and get things to move in that magnetic field. An instrument that is used to detect the current is a galvanometer. An electric motor changes electrical energy into mechanical energy. Okay, and like a galvanometer, an electric motor contains an electromagnet that is free to rotate between the poles of a permanent fixed magnet. A coil's magnetic field can be flipped by reversing the direction of the current. Just got to get the electricity to go backwards. In a motor, a reversing switch that rotates with an electromagnet is called a commutator. A motor, or in a motor, the stronger the magnetic field in the coil, the stronger the force between the permanent magnet and the electromagnet. The speed of an electric motor can be controlled by varying the amount of electric current to the motor. Name 3 devices you see or use every day that make use of the relationship between electricity and magnetism. You can have all kinds of things here. So we're going to talk about, generators, anything with an electric motor, whether it's a Tesla car or a simple fan inside your hairdryer. Speakers. Okay. Any type of gauges. Some of the, or not any type of gauge, but some of the gauges that include a galvanometer. And any transformers. All right. Section 3. So if we're looking at this diagram here, label the parts using the correct terms right here. So this right here is showing a permanent magnet. So number 1 is a permanent magnet. Number 2, this coil is going to be going in and out of this, and so what this is going to be an electromagnet. And this, we're turning it, so this is our source of mechanical energy. So is this a generator or a motor? We're going to make this a generator that's going to light this light up. So this is a generator. When the wire loops of a blank turns, an electric current is being produced. So we're going to generate some electricity. The current produced in a generator is alternating current. We'll see why later, hopefully when we get back to school. A motor uses an electric current as it turns. A device that increases or decreases the voltage of electric current passing through a power line is a transformer. If the secondary coil of a transformer has more turns than the primary coil, the transformer is a step-up transformer. So, in the space below, draw the sketch of a transformer that has half as many coils in the secondary coil as its primary coil, and then label the two coils. So we know that they have at least this, okay? And if you want to get fancy, you can do the three-dimensional version of this, right? And so if our primary coil, it's a step down. So primary coil, let's say it's on this side. So we're going to go over here. Let's say it has 1, 2, 3, 4 turns. Then the secondary coil has half as many. So this thing's going to come in the backside. It's going to have 1, 2 turns. 2 turns, 4 turns. And so this is the primary. We have to label this, right? This is the primary coil. And this is the secondary coil. So that would have gotten us all of those points. We're finally ready for this. So we're going to use all of these terms to answer these questions. The regions on a magnet where the magnetic force is the strongest is called the magnetic poles, right here. Usually we just call them poles. The south pole of a magnet will repel the south pole of another magnet. A device that uses an electromagnet to measure electric current is a galvanometer. A device used to increase or decrease the voltage of a current in a power line is a transformer. A switch that regularly reverses the current in some motors is a commutator. Current that flows in only one direction through a wire is direct current. A large wheel that rotates when pushed by water, wind, or steam is a turbine. When current in a circuit reverses its direction in a regular pattern, it is called alternating current. We also just say that's AC current. Up here, this would be DC current for direct current. The properties and interactions of magnets are referred to as magnetism. The group of aligned atoms in a magnet are called domains. An electromagnet is formed by placing a piece of iron inside a current-carrying coil of wire. So that would be an electromagnet. A machine that changes electrical energy to mechanical energy is an electric motor that is used to do work. A device that produces electric current by rotating a coil of wire in a magnetic field is a generator. The process by which moving a wire through a magnetic field produces an electric current is electromagnetic induction. Induction, you don't have to touch, okay? We talked about touching by contact and charging by contact and charging by induction in the last chapter, so we can have electromagnetic induction to make things move. That's it.